Okay. Hi, Mr. Tom. My name is Guangin, and I'm the person who talked to you, introduce you the overall of our assignment related to the main requirements. So first, the statement is that is the RMIT e-commerce store face challenges due to the manuals, development efficiencies, and accessibility issues. So the proposed CI/CD pipelines of our group automate the development, testing, and deployment process, improving reliability, scalability, and efficiency. So our CI/CD pipelines have some key features below. So first is automations. We use Judkins to automate the build test and deployment test, while Doctors ensures the consistent environment across the development, testing, and productions. We use Cypress handles end-to-end testing, and Jest performs unit and integration tests. Ansible automates infrastructure setup to ensure the consistent configurations. So next one is the scalability. Docker Swarm manage orchestration, enabling fault tolerance, load balancing, and efficient resource use. We also integrate the client service that AWS EC2 is. We use EC2 Instant provide scalable and reliable cloud hosting to handle the traffic fluctuation and ensure the high availability. Next one is the resilience. For the scalability, we also use the cloud formations to ultimately create an EC2 instance for easier scaling. Next one is the resilience. So our system integrated the logging and monitoring tools such as Grafana and Prometheus that provide insight into the system performance and deployment status for quick issues resolutions. Next one is a microservice architecture to our system. For our system, separate the front-end backends and database into a contiguous service, improving the modularity, fault installations, and ease of updates and maintenance. And then the last one is continuous integration. We automate testing and merge changes from multiple developers to reduce the conflicts and maintenance of functional code base, enhance the team productivity and cooperations. We use GitHub Webhook to do that. So that is next one is the demo. Now I want to introduce you our application flow about my part, the CI. So first, the GitHub will detect the commit code from our local repo, and after that, the GitHub will send the signal by GitHub to the Jenkins. The Jenkins will next the Jenkins will check the environment, do some pre-build stages, install dependency or something like that. After that, the Jenkins will detect the changes whether from client or server. If the client, the Jenkins will use the Cypress to run the test case to test the web UI. Next. However, if the changes is from backend, the Jenkins will use the Jest framework to run the test case to test the unit test, integration test, and API test. If the test fail, our system will send the email to the developer. Next, if the test is success, the Jenkins will go into the build stages. The Jenkins will use the Docker Compose on the source code to build the front end and the back end. After that, the Jenkins will push to the Docker Hub and the image to the Docker Hub, and that is the end of pipelines. And after that, Jenkins will also implement the CD. That is, the Jenkins will connect to the Ansible servers for the deployment stages. Hi, Mr. Tom. So next one, I will go to show you our pipeline will detect the errors from our tests for both backend and front end. Yeah. Okay. So first, I will demo the error detection for the backend of our pipeline. So I will change something like that. Okay. Next one, I will go to the GitHub. Yeah, the change is detected. I will commit it. Okay. Wait a minute. Okay, that's okay right now. So next I will go to the Jenkins local and go to build. Wait my pipelines a little bit. We use Jest for backend test, including unit test, integration test, and the API test. We made minutes because it takes time for install dependency, although I run the pipeline locally. Yes, you can see the backend test. It's going wrong because there are a few test cases in our test file, so the pipelines get detected. And as you can see, that the backend test failed, Docker setup failed, so that the build process cannot be done, and the push to the Docker will be wrong too. Yeah. So let's go into the alert system of our pipelines. This alert system will announce the developer about the status of the pipeline fail or success through email. Okay, let me show you how we do it. Okay, first I will go to I will install some plugins. Go to install plugins because I have already installed the emails plugin. Okay, email. Okay, I will use the email extension plugin for sending the emails. After that, I will go to the system configurations. Okay, because as I said before, because we can only run the Jenkins on local and not EC2, so I cannot test these features, but I will show you how I do it. Next, I will show you the features of our system. That is, we utilize the GitHub webhook to trigger automatically the pipelines. So first, I will go to the repo webhook. Okay, here I already set up the webhook. I paste the Jenkins URL on the payload URL for the GitHub to send a signal to the Jenkins to detect the changes. So for the SSL authentication, I disable it, and for the events I want to send the GitHub, I just want to receive the push events. So let me update the webhook. So on the Jenkins, I have already set up a little bit. For example, I take on the GitHub hook trigger for GITS CM pollings and paste the repository URL, and that's it. Okay, so let me test for you. So I will use this one. I will change the code on source code, and after that, GitHub is detected. Okay, commit it. All right. Okay, wait a minute. Okay, wait a minute. Okay, wait a minute. Wait a minute. Wait a minute. Oh, the Jenkins is detected. And to build the pipelines. So wait me a minute. As you can see that our team have the very severe bugs. That is, the backend the pipelines cannot run anymore because they are lagging when I implement the Jenkins on the EC2. I have already tried a lot, but it's still stuck on the backend dependency, especially it's the npm install. Although there are success log on the backend dependency, but we can run it. The pipeline it's not processed more. So so instead of that, I will show you how to run my pipelines manually. It's mean that uh, so that is the reason why I will use the local container to local Jenkins for building the pipeline. So let me show you. So here is the email notifications. Let's go into, okay, here it's the GUI of these features. So if I have a time, if our team have a time, or can run the pipelines on the EC2 on the server, I will use the mailgun to create the SMTP protocol. It will go in, this will be filled in that field, in the field of the email notification, and I will and we can test these features. But now I know how to do it, but it's pretty hard for me to test. I show that the GitHub trigger will be is can be applied on the EC2 Jenkins, but for the local ones I need to do manually. So first, because our source code is divided into two source, client and server, and my pipeline is can detect the change of each source code. So I will do step by step. So first I will test the client. For example, you'll go to the client, to the app, and make some changes. Okay, here's the source code. I changed some comments on the Docker file, Docker compose YAMLs. Next, I will commit it into GitHub. Okay, commit it into GitHub. Okay, all right. So go to the Jenkins local, build now. For the pipelines, for both local and on the EC2, I use the stage view to monitor the process of the pipelines. It is very useful. A lot of status it's here, so I can know about the status of this stage. I have already used some plugins such as Ocean Blue, yes, like that to monitor, but it's quite lag. So I think that's plugin. It's good. Yes, you can see every stage is going to step by step. It takes a bit time for completed the pipeline. As you can see, the pipeline is success. And you can go to the console output to see the step by step of the pipeline. So the pipeline will detect the change through the commit. Yeah, we check the environment node Docker. Detect the change. Okay, that is the stage install dependency. Next one is the front end test. Okay, passing Cypress test. And that next it's log into the Docker. Next one it's build step. Yeah, we build step using Docker. Yeah, build. Yeah, we have an image right now, and we push to the Docker Hub. Yeah, and finish. So next one I will go to the server. Okay, I will do the same one. Change something in here. No, here it's better. Yeah, yeah. Change the comment. Yeah, GitHub detection is committed to GitHub. Push origin. It's all good now. Okay, go to the pipelines. Build now. As I said before, we can use the GitHub to webhook to trigger the pipelines. But yeah, as you can see that the Jenkins is really lagging, so I cannot cannot continue the pipelines. You can see that the webhook can trigger, but it cannot run smoothly and go to the successful. And then the email, I already show you that how I set it up, but it's pretty hard for me because the local cannot send the email. Only on the EC2, yeah, on the server can do that. So sorry about that. Okay, same as the pipeline for the front end. The backend is still run. It's very similar. Go to the instance dependency, backend dependencies, run test. Run backend, Docker setup, build, and push to Docker Hub, and the success message. That's all the pipelines can do. Our pipeline can do. Yeah.
Hi, I'm An, and now I'm going to talk about the automation tool, configuration management, and the orchestration for our project. So first off, for the automation tool and configuration management, we use Ansible. In our Ansible server, we have two main files to set up the server. The first is the inventory dot YAML file, where in here, as you can see, with our document, we set up all the master and worker in the swarm in here. And next off, we will have a file to run the script to deploy the stack in the Ansible server to the Docker swarm. So uh, let's move on to see the result of that. Now I'm gonna talk about the architecture after we finish our CI. So as you can see here in the picture, after we finish the CI, which means that we have pushed our Docker image to the Docker Hub. Now we're gonna start the CD process manually, the deployment process manually. So first we will have the Ansible server where we will run the deployment Ansible playbook, and then that playbook will connect to the Docker Swarm, and the Docker Swarm will in charge of deploying the stack to the connected container in the Swarm. So first off, we will check the connection to our worker node. We will check the connection to our worker node by running the ping command. As you can see, all of our inventory has been successfully pinged, so we know that they are connected. So next off, I will run the deploy, the deploy swarm YAML with our inventory file. So as you can see here, as you can see, the swarm has successfully deployed the stack, and you can see the replica are up. And now I'm going to talk about the orchestration part of our project. In this project, we choose Docker Swarm because it's easy to set up, friendly to beginners, which is most of our group contains of, and it require less. It's require less experience to use it. So now we are here in my Docker master, which will be the master of all the worker in this one. So we can run our first command to check the state of our swarm. As you can see the result in the screen, all of the workers are connected and are ready to be deployed. So after we run the Ansible script, which will activate the Docker master to deploy the stack, here will be the result. As you can see here, the states of our current image and replica are all shown in here.
Hello, I am Tom, a member of Team Point. I will present about the testing framework. So, uh, for our CI/CD pipeline, the testing framework that we use are Cypress for end-to-end UI testing and just for unit and integration testing. These tools were selected for their advanced features, seamless integrations, the easiness to use, and suitability for the project requirements. Um, with Cypress, we test critical user workflows like login, product browsing, purchase, and account management. Um, we also conflict with mocking and intercept to isolate the test from the backend dependencies. Also, we the automated test run with every update to validate user interface integrity and ensure a seamless user experience. The UI testing also covers essential features such as account management, address handling, registrations, order listing, product purchases, password reset, and user authentications. And for yes, we use for unit tests to validate individual components and integration tests to ensure a smooth interactions between the front-end, back-end, and database components. We are, it covers back-end functionalities, including API endpoints, query pipelines, middleware, and utility functions. Validates basic rules, error handling, and secure access to protected rules, ensuring a reliable and cohesive backend system. So the benefit of having the testing framework is to early issue detection with automated tests, um, um, allow the stability of critical features after deployment, comprehensive coverage of both front-end and back-end functionality.
Hello, so I want to talk about the advanced requirements in this assignment. So in our team, we have managed to address 2 points. First is to deliver a monitoring and alerting system using Grafana and Prometheus. The other one is applying some additional features, which is using Nginx Proxy Manager to provide SSL certificates for the domain, and also we map the domain into the server as well. The other 2 points, which is the additional cloud integration with AWS CloudFormation, and the other one, which is applying the advanced deployment strategy, we didn't have enough time to do it. So this is the 2 points that we could use to leverage the CI/CD pipeline that my team has already discussed in the previous talk. So why do we use monitoring and alerting system here? So we choose Grafana and Prometheus compared to other monitoring and alerting systems because those two are probably the most popular right now, and it has the key features, which including the visualization. So it supports a variety of charts, graph, and alerts that we can download from Blockit, and also the dashboard that provide a rich overview of the data that I will show you later on. And then the last 2 points is one is to integrate with the data source. So it's including the integration with database, with backend framework, or even with any sources that provide metrics. And finally, we can investigate the running containers from Prometheus to check if there's anything wrong with our running apps. For the code part, at the moment, I have already prepared a front end which is running at localhost A080. So at the moment, we haven't set up any backend database yet. So just for demonstration of the Grafana and Prometheus, so we will run the Docker Compose. Okay, I need to see the server and then Docker Compose. I already download the image, so you cannot see the actual like deploy time. But if it's correctly, then it would not take too much long. So this is the client container that I have already prepared beforehand. And for my friends, it will be on the server. The front end will be running on the server like this. And then we will have the other Docker container here. So first one is the server container. And then we have the Grafana, Prometheus, and also the exporter here. So what are the exporter about? So first we will jump into the Grafana first. So this will be located in the localhost 3001, like this. And this is the first time when we log into Grafana, it will access the default email and username and also the password. Just type in admin for both of them, and later on we have to change the password. So right now I will change to 1234556, or you can skip it anyway. Okay, so this is what the Grafana will look like. And at the moment there's no visualization yet. We need to configure the dashboard, so we can use the dashboard option here, and then we create a dashboard. So where the dashboard come from? We can actually like create our own by clicking add visualization, and then we configure a new data source here. So I will choose Prometheus because this is what we already configured. So for Prometheus, the only thing we need to notice is the server URL. So if you take a notice as our Prometheus, so this is the container we are running. We need to replace the localhost with the Prometheus container name. So at the moment I have the container name is Prometheus. So I will input here Prometheus, and then the port of it, which is 9100. To check if there's some metrics, we can check like localhost 9100, and then we can see that there's the not exporter here. We can also slash and then write metrics, and then we can see there's a tons of numbers here about bytes and load time, CPU, etc. So basically, if we have some page like this, it's perfectly work right now. So back to the Grafana a little bit. So basically, after we configure the data source, we just save and test. Okay, so connection reviews. Let me check. Okay, so Prometheus. I think that I put the wrong port. It should be let's see, Prometheus 9090. Sorry, because 9100 is for the not exporter. We need to input the port for the Prometheus. Okay, so we save, and then we can go back to our dashboard, and then create another one again. So if we add the visualize here, at the moment there's no data. We can choose like the anything, like we can run the queries here, and then we have some operation. We can add new queries, whatever metric you want. So duration, second, etc., etc. But basically, like this matrix, we have to configure by ourselves. So this is quite difficult. On the other hand, Grafana already provides us some very beautiful dashboard that we just only need to import it. So basically we will create, but this time we don't add the visualization, but we import the new dashboard here. So we discard the change, and then we can go to the Grafana dashboard link, which is this one. So basically using this link, we can get access to all the templates that they have provided us already. And this is our node exporter, which is a very beautiful dashboard that some of the developers have already configured for us, and also provide the instruction for us as well for our Prometheus YAML file. So basically we just need to copy the ID to the clipboard, and then we go back to our Grafana, and then we copy the ID here, load it. You can see the dot exporter file is basically here, and then we just need to choose the data source that we have created already, and then boom, we have all the dashboard here. So anytime that I'm going to change something, like if I go to shop and then I search something here, sorry, because we didn't connect to the database yet, but basically the idea is that if we change something here, then the CPU, the system log will be changed, and also we can see the uptime here, and then CPU, how many CPUs, we have the CPU network traffic here, etc. We can see all of the data here. And apart from the node exporter, we also have the black box. So basically, we just create a new dashboard, and then we import one new one. So basically, this time we're not using the node exporter anymore, but we use the black box exporter. So this one will track the amount of traffic that is available right now in our front end. So we just copy the dashboard again, and then load it, and then choose Prometheus again. We import it. As you can see, like we have two instances here right now. The status here down is mean that because we are running at localhost. If we're running at an IP address that is publicly accessed, that this will not be down. And then we will also notice about like the SSL certificate and also the prop. I add the Google here so that you can see like what it look like for the Google side. We can see like the prop duration, like how long it takes for us to reach the website. And then for the SSL, is the last one for the Nginx proxy manager. So in our Docker Compose file, as you can see, in our Docker Compose file, we also have one more part, which is the app. So this one is taking the Nginx proxy manager. And what is the Nginx proxy manager? So basically, if you go to the website, you can see there is a installation for the Docker Compose. We just need to copy it and paste to our Docker Compose, and then we will access by going to the IP address, and then we use the port 81. This is the default Nginx proxy manager. So we need to input our email. So the email here is provided by the Nginx proxy manager as well. So this is the default admin user email and also the password. So I just type it in, and then we can later configure it. So you can see the full name, nickname, email. You can also change the password in here as well. So to fasten the presentation, I just want to go to one part only. So we need to map the domain into the server, and also like we configure the SSL first. I'm using Namecheap to create a free domain here. So this is the dashboard. So basically you need to go to manage, and then we can add the domain for ourselves. So we go to advanced DNS, and basically we will change from the localhost, which is for example the localhost, the IP address is 127.0.0.1, and then we will change it. We will navigate it into the domain. So Tom, if you want to like improve your CI/CD pipeline, maybe later on in the future you want to deploy your website with the domain, this is how you're going to do it. So you need to add a record here. So basically it will add a route, and it will navigate to the IP address. So I will input here localhost, which is 127.0.0.1, and then the client here just means the subdomain because I already have a default domain here. I cannot use it anymore. So if we configure it, basically after we add a new record here, so we don't have to choose localhost anymore. We can directly type client.mydomain.me, and then basically it will continue to navigate us to this. And if you want to delete this port right here, basically you just go to the Nginx proxy manager, go to host, and then proxy host. And then I already create one here, so basically I will create again. So delete it. Okay, I will add a proxy host. So basically we will type in our domain name, which is client.me. Oh my god, I mistyped it. And then we change the remember to enter or else it will disappear. And then we input the IP address here, 0.1, and then the forward port, which is 8080. So at the moment here, if your IP is not the localhost one, it will definitely remove the port. At the moment, because I'm using the localhost, so that's why the proxy manager does not remove the port right here. If I try to remove it, it will jump to this page. But at the moment, because the localhost is not registered in the Nginx, you need to use an IP address in real like EC2 server, so you can remove the port. And then same approach. If you want to create this SSL certificate for this domain, you just edit, and then we choose the SSL type, and then we request a new SSL certificate. This one's coming from the Let's Encrypt, which is a very famous one. So if we click save here, basically it will generate an SSL for us, but the only requirement is that we need to, it's not the localhost one, but it is going to be the real server IP address, or else it will be internal error like this. Okay.
Hi, I'm An, and now I'm going to walk you through the cloud formation section of our project. So first off, we will make sure that there are no instance that created with this name. First is master, and the second is worker. Yeah, so nothing's here. So we move on to create our cloud formation stack with this name. So we create a new stack. I will upload a template file. I will upload my file. And then I will provide a name. I use the function here, and then I will continue. So now I will check the master name, the worker, to see if my YAML file is correct. So now you can see it's created in progress, so I will refresh it, and now it created complete. So we will come back and check to see if our instance is created with like this name, master and worker. Yeah, worker. So So they are created. Now I will go into one to check if the configuration is correct. Right now it's running, so I will connect to it. So now I will check my config inside the Docker compose file, and I will check the node is active, so it's connected properly. So right now, as you can see, they are all ready, and we can use our Ansible server to deploy this